Professor Doney back here on the next installment for vertical motion. In the last video, if you watched that, we talked about the different types of vertical motion problems, one-dimensional. We talked about drop problems, throw down problems, throw up problems, and throw up, and if you wait long enough, they actually come back down problems. And the book basically solves them all the same way using the three equations. Let me just write those three equations down here so we have them. And then we'll look at solving an actual problem here. 2g delta y. And again, when we talk about the initial velocity or regular velocity in these equations, we are referring to in the y direction, the vertical direction. Okay? So, how are we going to solve these? Well, I'd like to look at vertical problems by looking at what type it is. And if we're looking at the first type of problem, and we're doing a drop problem, what we mean is we have an object, and the object is going to fall, and it basically falls from rest. So its initial velocity in the y direction equals 0. Basically means it's dropped. I don't throw it down, I don't toss it up, I'm holding it out in the air. If it's my keys, I'm holding it, I open my hand, and it falls to the ground. Now, it's going to fall to the ground or fall downwards, wouldn't have to go to the ground, under the influence of gravity, so it's going to accelerate in the y direction at 9.81 meters per second squared, which is what gravity is doing, and gravity is pulling it towards the earth. Now, what we're going to do to solve these problems is we're going to, I think, make things a little easier by picking the downward direction, just changing the color here, as positive. Since the object is falling down, all the motion is downwards, we're going to pick the downward direction as positive. We can do that because we can just rotate our axes that way. So we're going to pick the positive direction down. That means everything as it falls will be positive or increasing that way. So let's say we have the problem here, drop an object from height of 10 meters. And let's find a couple things. V at impact, which would be actually our max velocity, and time to fall. Let's find those two things there. Okay? Now again, we're picking positive downwards. Everything's going to increase that way, and we let it fall 5 meters. Alright, so let's move forward here. Now, if we look at what we know and what we don't know final velocity, we don't know time, so I'm going to underline those. And there's time. I know distance, I know initial velocity 0, I know gravity. So what I can do is I can use any equation that doesn't have two unknowns. That first equation has two unknowns, so I can't use that. The second one has only one, so we're going to start there. See if I can do this quickly before we run out of time here. We're picking positive down. I'm going to use the last equation, and we know it's 10 meters. Initial velocity is 0 times time, so it doesn't matter what the time is necessarily. Half times 9.8 t squared. Now if I continue to solve that, I'm going to get 10 equals 4.9 t squared. Now what I have to be careful here is I'm going to put a positive in for that gravity. Why? Because everything is positive downwards. Gravity is pointing that way, so I cause it positive downwards. If I go through and solve that, I'm going to get t equals a square root of 10 over 4.9, which is square root of 2. It's somewhere around, I don't know, 1.4-ish seconds. Okay? Again, ballparking. But the key to this kind of problem, I'm running out of time here, is to pick, if I pick positive down because that's the direction, I make sure gravity's downward. Now, to find what V impact is, then I'm just going to take that value, put it back into here, multiply it by gravity. That's 0, so it's 0 plus 9.8 times 1.4. We're going to get around 14 meters per second. So there's a real quick drop problem. I'll see if I can't throw together another one before we end up here. Alright? Hope you enjoyed that. We'll talk to you then.